This presentation is going to be a web-friendly version of a lecture that I developed many years ago, actually about 2010, for a physical science class. And I've continued to give this lecture in an astronomy class, but this web version is going to be somewhat updated, not only to include a little bit of science explanation, physics explanation, but also I've revised it to include a lot more critical thinking skills. I had a couple of students, like I said, in 2010 who were enamored with PowerBalance bands, and they wanted to know my opinion. I had never heard of these things before, but I noticed that they were becoming popular around campus. They were being sold on campus, and in fact, they were even being sold at a local swimming pool supply store.
What I have to demonstrate for you today is a revolutionary new product. What we've been able to do is harness naturally occurring frequencies and program them into a Mylar hologram to help improve your balance, your strength, and your flexibility. I'm here with Akolo, and what we're going to demonstrate for you are 3 power balance tests. First, what we're going to do with Akolo is demonstrate the balance test. So Akolo, if you would, put your feet together for me, your arms straight out to your side. What you're going to want to do is when you perform this test is make sure that they have their arms stiff in a firm position so that if you push down, they can resist. The reason that you want to get the person that you're testing into this position is so they can understand what's about to occur. You want them to be able to feel the resistance you're going to place on their arm. So I'm going to push straight down, resist, don't let me push down. Good. Now what you're going to want to do is have them lift their left leg and find their balance point. Good. Once they're up and have found their balance point, you're going to push down again on the same place of their arm. So Akolo, again, resist until you tip over. Good. Now what you're going to want to do is perform the same thing, only with the power balance on. One of the great things about this product is that they don't actually need to be wearing it. They can either be holding it. I could set it on the top of his head. It wouldn't matter. All that matters is that the product is within 1 to 3 inches of your body's energy field. So now, recreate the exact same test. Feet together, arms out, lift that left leg. Using the same point on the elbow, I'm going to push down again and resist. A little bit of a difference?
Yeah, considerably.
All right, now that we've increased your balance, let's show them how this product can impact strength. What we're going to do is we've got Akolo here, a pretty strong guy, right? Work out, paddleboard, got the whole deal, got some nice shoulders. What I want you to do for me, put your feet together, hands right here at your side, okay? What I want you to do is grip my fist tight, okay? I'm going to push straight down. I want you to resist. Do not let me push you over, all right? So make sure when you're pushing that you're not pulling away, but you're pushing straight down. All right, so same thing again. We're going to put the product on, and once again, it doesn't matter. The fact that he's wearing which wrist doesn't matter. As long as it's within his body's energy field, it's going to function. All right, here we go.
Come on, you got more than that. Wow.
Obviously, a tremendous increase. So we've demoed strength and we've demoed balance. Now let's do the flexibility demonstration, Akolo. All right, for this one, we're going to have him start facing the camera so that you can understand it, and then we're going to allow the camera to mark his rotation. So what you would like to do is, again, feet together, same position as always. Right arm straight out, okay? Pointing straight ahead. So for the sake of this, turn and face away. All the way for me, okay? Now what I want you to do is rotate back as far as you possibly can. Mark the point with your eyes, trace your arm with your eyes as far as you can. Is that it right there?
Yeah.
Okay, go ahead and return. Now let's put the product on. Do the same thing for me.
A lot farther.
Noticeable difference, huh?
Yeah, for sure.
Absolutely.
Show me what stand on one like this, and I'm going to try to push your arms down.
All right. So explain what you're doing first of all.
Like,
What's the test?
How balanced he is whenever you just barely push down. I was barely pushing down on him. Now practice on him. Now do it again. And I'm pushing the same force. And I don't know the other one. It's
The other one is, put your feet together. You step as far as you go to the left. All right, let me see. I don't know.
You did go further.
I know.
Did you see that?
Yeah, I was trying to get an angle to be able to see how far you'd gone. So, all right. So this is without.
Without the lower bed.
Okay.
Somebody's supposed to be standing there to mark it, right?
All right. Okay. Very good.
In
the previous two videos, you saw, first of all, some demos produced by the company itself, the PowerBalance Band company, put out those little demos. And then in the second video, you saw the two students who initially brought PowerBalance bands to my attention. And when I first developed this lecture for the physical science class that they were in, I mainly treated the physics, the science behind PowerBalance bands. I was trying to explain to them how I thought these bands were working or perhaps not working. In the intervening years, ever since I first developed this lecture, I've become far more interested in not what was going on with the bands, but what was going on in the minds of my students. They believed these bands worked, and I've been really fascinated with trying to essentially pull that apart, ask them how did they build that belief. They believe that the PowerBalance bands work. That's the what. The why. The reason why they believed it is because they had seen demos like the one that the company put out, and they had done those demos on each other and on other students any number of times. The most interesting question to me is, how did they determine that those reasons were reliable ways of knowing whether these bands worked or not? So certainly there was a personal experience. They did the demonstrations numerous times, but even that appeared to have been an unsatisfactory method for being completely confident, because they were coming to me, they were asking me, what did I think? They seemed to think that there was some sort of science involved, but they couldn't figure it out for themselves. So notice that my students had generated a belief that PowerBalance bands work, and they supported that belief with reasons, essentially the demonstrations they were given, that they were showing. And so they essentially made a connection between the belief and reasons. And the beauty of this method of investigating is by asking the how, you're really stress testing that connection. You're asking, how did personal experience, how did you determine that personal experience was a reliable way to make this connection? Or is the science that is purported to be behind these bands reliable enough to make this a firm connection? If both of those could be shown to be shaky, if those methods for arriving at this connection could be shown to be suspect, would the connection perhaps be abandoned? And ultimately, would the belief perhaps be abandoned as well? Okay, so let's tackle the science first. Now, notice this is the how that the company would like you to make. This is the method, or the how the company connects the demonstrations with the product itself. So the reason why the product allows you to do the various things that they show you is because the band optimizes your energy flow. And this is seen in Eastern philosophies. It's got a hologram, and it resonates with the natural energy field of the body. Now, is that a reliable, with that information, can you reliably, confidently connect the demonstrations you just saw with the band? Now, that written description really didn't convince very many of my students. So let's take a look at the demonstrations that they did. And actually, I asked my students, was there anything interesting or peculiar about the performance tests? And one thing that was picked up on was that the test without the band was typically done first. Again, there's not necessarily anything wrong with this, but it was just curious that this seemed to be the pattern. Another thing that's very important is that the test subject, the person who was being tested, the person who was wearing the band, was aware of when it was in place and when it was not. That is scientifically problematic because the person is sort of in on it. They knew when they were being tested and when they were not. Most importantly though, or more importantly, the person who was doing the test was also aware of when the band was in place and when it was not. So that's why I describe these as performance tests or as demonstrations, but not as experiments. Because in an experiment, you would always want to be able to control the experiment. You would want to make sure that your subject was not aware of when they were being tested and when they were not being tested. And ideally, you would like the person who's doing the test to not know when the test is in place and when it is not. So all these are very, very important. Of course, there's also a lot of subjectivity in the sense that there are no pieces of equipment measuring forces and angles, and it's all very qualitative and not very quantitative. So to describe this as being a scientific experiment is just not at all accurate. Okay, so these students in my physical science class were essentially asking me, what's my opinion about the physics going on with these PowerBalance bands? Of course, they're called PowerBalance bands. I think a lot of it has to do with balance. I think very little of it has to do with the bands themselves. Balance has to do with your center of gravity and your base of support. You are said to be balanced, or you are said to be stable, as long as your center of gravity is directly over your base of support. So what is base of support? It's essentially where your feet are positioned. So here's several examples of foot positions. So when you're here in scenario A, feet shoulder width apart, this dashed area is essentially your base of support. As long as your center of gravity is over that area, you're going to be stable, you're going to be balanced. Once your center of gravity is outside that base of support, you're going to fall over. Here's a kind of a stance of what a boxer might adopt in the boxing ring. Here's someone standing on one foot. Notice how small the base of support is. The moment that the person's center of gravity moves outside of that dashed line, they're going to fall over. Here's a couple of football player stances. Here's a three-point stance, a four-point stance. Notice that a football player, a lineman, is going to be very stable because they've got a large area of support, a large base of support, and typically their center of gravity is located fairly close to the ground, and it's tough to push their center of gravity outside of that area. Stand with feet together, one shoulder and one foot up against the wall, then lift your inside foot and try to maintain your balance. Similar to the wallflower, this time you're going to put your backside and your heels to the wall, magically produce a small object that you can put near your feet. The challenge is to lean forward while keeping your knees straight. Don't bend those knees. Lean forward and pick up the object without losing your balance. No wall required for this one. You're just going to get down on your hands and knees, and you're going to place your elbows to your knees. At that point, either you or a partner can put a small object at your outstretched fingertips. Next step is to clasp your hands behind your back, lean over and try to knock down that object without falling over. Okay, so what does this all have to do with the bands? Well, notice that these demonstrations were all rather odd. Some of them you had to stand with your feet together, stand with one foot up, arms out, all that kind of stuff. Very rarely would you be in any of these positions on the football field. But the idea is if these bands can be shown, if they can convince you that the band works when you're in these odd positions, then you would assume that they would work when you're running a 50-yard run or trying to make a catch or something of the sort. So the demonstrations are all very curious. Why did they have them adopt these really strange positions? Well, we just talked about the center of gravity and the base of support. All of these positions, whether it's 1 foot on the floor, 2 feet close together, you had a very small base of support, and that makes you inherently unstable. Not much force would be required in order to knock your center of gravity outside of that dashed line. And therefore, the push or the pull can be very subtle. The demonstrator always says, oh, I'm pushing straight down. But are they really? We don't really know. I'm pushing harder this time. Again, there's no equipment to measure the amount of force or the direction of force. And because you're already in an unstable position, it is very easy to deceive somebody and make them fall over and make them think that it's the band that keeps them stable, when really it all has to do with the force and the direction of the force.
So Okolo, again, resist until you tip over. Good. Now what you're going to want to do is perform the same thing, only with the PowerBalance on. One of the great things about this product is that they don't actually need to be wearing it. They can either be holding it. I could set it on the top of his head. It wouldn't matter. All that matters is that the product is within 1 to 3 inches of your body's energy field. So now, recreate the exact same test. Feet together, arms out, lift that left leg. Using the same point on the elbow, I'm going to push down again and resist. A little bit of a difference?
Yeah, considerably.
Okay, remember this lecture was first developed for my physical science classes. My physical science students were aware of things like forces, right? A force, if I want to move this chair out of my way, what do? I exert a force, right? I push, and I push it in a straight line. So I exert a linear force, and that the chair moves in the same direction as my force is, okay? Torque is slightly different, but it is related. Torque is a force that causes circular motion or rotation. A couple of vocabulary words I need to introduce here. Okay, so when I'm dealing with torque, I'm going to use this door. My door is going to be an example of torque. I need to talk about the fulcrum or the pivot point, or in this case the hinge. That's where the rotation occurs around, right? We also have to talk about something called a moment arm. A moment arm is the distance between where I apply my force and the pivot point. So notice that in the case of my door, my moment arm is the distance from my handle all the way to the pivot point, to the hinge. And that's a fairly long moment arm. What if I had a door? What if I had a handle just attached right here? I wouldn't develop as much torque, right? If I had a handle right here, I wouldn't be able to get as much torque because torque is the product of my force times the moment arm. Okay, most of this is relatively unimportant. The important thing is, notice how I exert my force. I exert my force perpendicular to the moment arm. Remember, my moment arm is here. I'm exerting a force, I'm doing a pull or a push, and that causes rotation. My door rotates either way, as long as I'm exerting my force perpendicular to the moment arm. Notice what happens when I exert a force parallel to the moment arm. When I push the door toward the hinge, I get no rotation. Same thing when I pull the door. Again, I'm exerting a force, but it's parallel to the moment arm, and I produce no torque. The only way that I can get torque is if I exert a force perpendicular. I either push perpendicular or I pull perpendicular to the door. That's going to cause rotation. So notice with these balance and strength tests for the PowerBalance Band that it's the human body we're dealing with. And in this case, your feet are going to be your fulcrum or your pivot point. The body is going to be your moment arm. And then torque is going to be produced when force is exerted perpendicular to the moment arm. Remember, you will only get rotation if the force is perpendicular to the moment arm. And that's why it's so important, the direction of the force, the direction that the force is applied. So the demonstrator might say they're going to push straight down. But notice that if they push at just a small angle, it can be very, very subtle. If they push in this direction rather than straight down, that force that they're exerting has two components. It's got the straight down part, which is indeed parallel to the moment arm. That would produce no torque. But the force also has a perpendicular component, and it's that part that is now perpendicular to this moment arm that's going to cause rotation.
Feet together. Cup your hands. Don't let me pull you down.
Oh, shit.
Don't let me pull your hands. Yeah, I put way more force in the second one than I pull you down.
Okay.
That's weird.
All right, put your feet together. Cup your hands. All right, don't let me pull you down, all right?
Okay. I'm weak.
See how hard I pull? Now, hold it. Cup your hands.
Okay.
Oh my gosh.
That's weird.
All right.
I feel creeped out now.
Do it without the band again real quick. I'm sorry. Just so I
Got
can.
the band?
Yeah.
I feel creeped out.
Again, in the last few years, I've really become fascinated with why people believe what they believe. So in the case of my students, these two students, they had formed a belief. And I often think of the analogy of a mountain climber. Think about a mountain climber reaching for a handhold. They reached for an explanation. Somewhere along the line, they were shown these demonstrations, and they bought into the explanation that it was the PowerBalance bands that were causing the demonstrations to turn out the way they did. So essentially, the method that they were using, the method that connected these two, was personal experience. I don't think that either one of them was very convinced by the science on the packaging or on the website. So it was mostly personal experience. The question that I've been trying to get at, or to demonstrate to them, is how did they determine that personal experience is a reliable method for making this connection. Because if you watch those videos very carefully, and I encourage you to go back, watch those videos, the last two, very carefully. Watch the direction of the force, the amount of force and the direction of the force. And I think what you're going to see is that their personal experience was polluted by confirmation bias. The fact that they knew when the band was in place, when the band was not in place, and they also knew the expected outcome. They knew that when the band was in place, the person was not supposed to fall over, and when the band was in place, was not in place, they were supposed to fall over. That is confirmation bias. And because of that, it makes the personal experience a less reliable method for making this connection. So it's my hope that in seeing, and actually in video evidence showing that yes, they did apply the force differently depending upon whether the band was in place or not, would make them a little less confident in making this connection. If you want to eliminate confirmation bias as much as possible, what you do is a double-blind experiment. That's again much different than the demonstrations that we've seen from the PowerBalance website. And thankfully, some reporters on Australian television actually did a report about these PowerBalance bands. I'm going to include a link to the full video in the video description of this lecture, rather than making this video any longer than it already is. But in that video, you're going to see a double-blind experiment where the people being tested are not aware of when the bands are in place, and the people doing the testing are also not aware of when the bands are in place. And the results pretty much speak for themselves. So hopefully I've achieved my goals of teaching you not only about the physics of PowerBalance bands, but also teaching you some critical thinking skills along the way. It's an extraordinary claim to think that a band of mylar will cause you to be more stable, more energetic and flexible, etc., etc. And therefore, someone who is making that claim better be able to provide some extraordinary evidence. Now, anytime you come across a natural phenomenon that you can't explain, or you're looking for an explanation from an instructor, quite often there are going to be several possible explanations. The important thing is which one is more likely, and also which one is testable. Those are very, very important questions to ask yourself. Always be skeptical. Never just take someone's word on something unless they can provide you with convincing evidence. And even then, you'll have to be very, very self-reflective about whether that evidence is truly reliable or not. And ultimately, sometimes it's best to just say, I don't know. All too often human beings tend to reach for lousy handholds, lousy explanations, and quite often we'll use personal experience to confirm those lousy explanations, rather than just admitting that perhaps I don't know the answer to this. So keep in mind, anytime you're exploring someone else's belief or your own belief, the pyramid. Identify what the belief is, identify what the reasons are given to support that belief, and then ask about the method. The point is not necessarily to make a person less certain in their beliefs. That may be an outcome. It's not necessarily the goal. The point is to help people think about the belief from a different perspective, and then leave them alone to allow them to decide whether they want to increase their confidence in the belief or not. So as I've already mentioned, I'm fascinated with why people believe what they believe, but I'm equally interested in what would cause someone to abandon a belief, or at least lower their confidence in a claim. So think about my students, the students who came to me about PowerBalance bands. Do you think they're still wearing PowerBalance bands? My guess is probably not. I haven't seen them in years, but I'm guessing that they're not wearing them, and they're probably equally as powerful and as balanced and as flexible as if they were wearing the bands or not wearing the bands. They wanted to know as many true things as possible and as few false things as possible. So they came to me for information. They wanted to try to figure it out. And when they were given new information, they lowered their confidence. They came to me very confident that the bands were causing them to be more flexible and stronger, etc. But upon gaining new information, they lowered their confidence and probably abandoned the explanation that it was the bands that were causing their strength and flexibility, etc. This seems to be a common thing. When the stakes are low, meaning that despite the fact they had probably paid some money for these bands, they may have shown some friends, and so they'd have to maybe eat crow and have to be a little humble, but that was a relatively small psychological investment in the claim. And they'd much rather abandon the claim, especially given new information, than to maintain that claim in the face of a better explanation. This is pretty common when stakes are low. They hadn't made future plans based on their claim about PowerBalance bands. Their social standing was not tied to their belief in PowerBalance bands. Where things get tricky are when the stakes are higher, when your personal standing, professional standing, family relationships could be jeopardized in lowering your confidence or abandoning a belief. We are more likely to try to shore up a shaky handhold rather than abandon it. And that to me is very fascinating. So this is a little question I'll leave with you. As a student in this class, if this class helps you discover that some things you've believed for a long time are not true, how would you feel about it? I hope you've enjoyed this lecture.